Now, once again, good morning, dear 10th class students. Now, today we are studying our new topic, that is the image formation by concave lens. Okay. So first you have to write the image formation by concave lens. You have to write down in your notebook. So stop writing. First you have to understand here. Position of object. Okay, only two type of image can be formed by the concave lens. Okay. So object anywhere between C and infinity, then in between 2F or C. Okay, anywhere the formation of image can be made. Then virtual and erect. Okay, virtual और erect जो है आपकी nature of image होगा यहाँ पे. And size of image जो है diminished है. Then object जो है if we are keeping at infinity, इसका मतलब object को अगर हमने infinity पे रखा, then position of image will be formed at F. Okay, virtual and erect same and highly diminished. So these are the ray diagrams. So you can easily see what are the nature of image will be formed during this when the rays are passing, because these are the incident rays coming from the parallel. Okay, these are the incident rays coming from the parallel from the infinity. Okay, so the formation of image at the focus, and this is the position of object. We have to keep in between anywhere in the concave lens. So formation of image here. This is the diminished and this is the highly diminished image. And look some uses of concave lens that are the to correct the eye defect myopia. We already understand. देखिए हमने इससे पहले जो क्लास के अंदर देखा था कि convex lens जो है वो हमारा eye defect hypermetropia को करेक्ट करने के लिए यूज होता है. Now this concave lens is just remove the defect of myopia, and in this way, because our eye is having this type of lens, and before that we have to keep this concave lens. Okay, when light rays are coming from the parallel, okay, first they diverge, okay, and then converge at the retina. So this is the retina position. Okay, this is the retina position. So to make more convergence, first divergence and then converge at the retina. So this is the functions of the concave lens here. Now the Galilean telescopes also use this concave lens and indoor spy hole camera, because when we will keep our eyes here on the focus, then we can see the broad spectrum of area through these small spy hole places. Okay, so this is our ray diagram. You have to write down first. So now students, now we are talking about the power of lens. What is the power of lens? The power of lens measures the degree of convergence or divergence of the lens. One more definition is that the power of lens is reciprocal of focus. Okay, stop writing and listen here. This is our power of lens. A power of lens measures the degree of convergence or divergence of the lens. Okay, it means any lens, it may be convex or concave. Okay, then how much convergence and divergence capacity of that. Okay, you know about that. If the lens thickness is greater, then the convergence power will be the more. Okay, so look at the size, and it is the thickness of the lens. If the lens is having more thick, then the converging power also greater, and if the lens is thinner, okay, it means from the middle there is a thin side at the edges in comparison, then the converging power also less, and the focal length will be the greater. So you have to see through this diagram that how focal length is related to the converging power. Okay, कि देखिए converging power के द्वारा जो है आप कैसे उनकी focal length के बारे में देख सकते हो. If they are having a more converging power, then they are having a less focal length. If they are having a more converging power, then they are having less focal length, and if they are having a less converging power, okay, then due to the less thickness, so they are having a more focal length. Okay, so this is the things. The power of lens is a reciprocal of a focal length. Okay, so it is the just the formula, the one mathematical expressions like that. P is equal to 1 upon f. P is equal to 1 upon f, and f will be in meters. Less converging or diverging power means more focal length, and more converging and diverging power is a less focal length. Okay, then a diopter is a unit of power of lens. One diopter is the power whose focal length is 1 meter. It means those are having the at least 1 meter focal length, then we can say that is the having the 1 diopter of unit of power length. And if the plus focal length plus diopter, okay, you have to see plus will be the it means in this way, and when we are talking about the concave lens, then the formation of it means focal length will be the in this side. Okay, it will the front of this. So plus d, it means diopter is convex lens for that, and negative focal length or minus d is for concave lens. Okay, first you have to write down these things. If you don't want to draw this diagram, then can I rub this? Okay. Simultaneously, you have to write with me. So if we are talking about the refractions of light, then we already seen that one transparent substance, that is the rectangular slab. Okay, in our earlier classes. Now we are talking about the glass prism, that is the triangular glass prism. Okay. You have to write, okay? Note down. Okay, diagram not completed. Okay, look, this is the refraction of light through a glass prism. देखिए इससे पहले हमने जो है वो ट्रांसपेरेंट हमारे पास एक जो सब्सटेंस था रेक्टेंगुलर ग्लास, ओके, उसके द्वारा भी देखा था. बट व्हाट आर द डिफरेंसेस बिटवीन द रिफ्रैक्शन थ्रू द ग्लास प्रिज्म एंड रेक्टेंगुलर ग्लास रेक्टेंगुलर slab, okay, that is the rectangular slab. So in there is a fixed type of refractions, but here it is the thickness of this glass prism maybe the changed, okay, maybe they are changing. So what is the line expressing about the glass prism? When the incident ray of light, जब भी देखिए incident ray of light, look everyone, don't write, I'll give sufficient time to write, okay. So when the incident ray of light passes through the faces of prism, and the faces name here, that is the PQ, okay. PQ is the face of this glass prism, okay. These are the edges, okay, and these are the faces of that. And if I can write here A, then this is the angle of prism, okay, angle of prism, that is A, okay. And I can change this one, small a, b, anything you have to write, no problem, okay. You can select anything, any alphabet for that, okay. The incident ray, so first refracted towards the base or thicker part of the glass prism. So you have to see that this is the going downside, okay. Then again when they are refracting, then again they are going to downside. It means continuously, first when the light is entering into the glass prism, then getting refracted through towards the base of the glass prism, then again when light is just entered to the rarer medium, okay, that is the air medium, and again getting refracted towards the base of the prism. So look, when an incident ray of light passes through the face, okay, of prism, refracted towards the base or thicker part, okay. So this is the base or thicker part. I can write here also, that is the QR, okay. QR is the base or thicker part of the prism, and when enter again rarer medium, that refracted towards the base of the prism. So you have to see. So and if I can explain the definition of angle of deviation, then it is the angle which can be formed between the emergent ray and the actual path of incident light or incident ray, okay. So this is the formation of delta is the sign for angle of deviation. This is the emergent ray, okay, coming out from this. And one of the most different things you can see here with the rectangular glass slab, that is there is the emergent ray is just with the parallel to the actual path of the incident ray, but here it is making an angle, that is the new one, formation of angle here, that is the angle of deviation, and angle of deviation cannot form into the rectangular glass slab, okay. So you can see this is the emergent ray, okay. Right fast. Now students, we are studying about the dispersion of light. Okay, listen. So this is the one white light in the form of incident light. Okay, and you already seen that. Stop writing, everyone. Okay, you already seen that in the class 7. That is the Newton disk. Okay, when the rotating at a certain minimum level of speed. Okay, then the 7 color constants, which all are having a two type of color. It means the 14 parts is there. Okay, you have seen in this way. Every and each color having a 2 parts. Okay, so 7 colors will make a 14 parts. 7 colors will make a 14 parts. So when it are rotating on the a type of minimum speed, then these all colors are seen in the form of one color, that is the white light. That is the white light. So it is showing that a one white light is a constant of a 7 color. One white light is a constant of 7 colors, and with the help of ruler or transparent substance, many times you seen that when a white light enters just inside that ruler or particular transparent surfaces, then its constant colors can be seen. Maybe sometimes 2 or 3 colors, but actually they are made up of 7 colors. They are made up, and if you are also seen in the rainy days, then they are their constant colors are 7 colors. Okay, so what is the dispersion of light? It means when the light is dispersed, it can be splitting into the 7 colors. It can splitting into the color 7 colors. Then you also can write the splitting of white light into the 7 color is also known as this dispersion of light. Okay. So first of all, when a white light enters into any transparent substance may be the rectangular glass slab. Okay, maybe this type of this prism. Then when it refracted with its 7 constituents color, इसका मतलब डिस्पर्जन का लाइट का मतलब क्या है कि जब भी कोई भी व्हाइट लाइट जो है, सनलाइट एक प्रकार की व्हाइट लाइट है, इस प्रकार के ट्रांसपेरेंट सब्सटेंस के अंदर एंटर होकर रिफ्रैक्टेड होगी, तो उसके अंदर से 7 कलर्स का फॉर्मेशन होगा. और वो 7 कलर्स कौन से होंगे? वायलेट, इंडिगो, ब्लू, ग्रीन, येलो, ऑरेंज एंड रेड. सो देखिए व्हाट आर द डिफरेंसेस. अलग-अलग देखिए वेवलेंथ एंड फ्रीक्वेंसीज के कारण इनकी डेविएशंस का एंगल्स भी अलग-अलग होंगे इनके. So the different colors having the different type of deviations on making the angle with the surface. So you can see that this is the actual path of light. This is the actual path of light when they are entering into the glass prism, and this is the actual path of the incident light when there is a no. Okay, this is only to it is explaining purpose only. Actually the diagram is this one. Okay, you have to it means understand here only. So this is the way of incident light without refractions, and this is the way of light which is simply, it means they are just entering after the glass prism. But you can see they are forming the angle of this one. They are more angle then they are angle then. Okay, so it means every and each color is making a different angle. Every and each color having a different angle. And why they are making a different angle? Because their frequencies, wavelengths, and their it means the speed of light when they are entering into the any denser medium is just different. Okay, it means then when the white light is entering into the any transparent medium, there are 7 constituent colors having a different type of speed into the different type of media. Okay, so that's why red having a least deviation. That's why they are having a longer wavelength, and that's why the danger signals are made up of red color, because without least, it means without deviated, they can propagate into the simultaneously in the rectilinear propagation of light, and that's why we can see the red light signals from the very far away places in the fog-like conditions or rainy-like condition, or when the denser medium also available. So that's why they are having a longer wavelength. Other one is a violet color, which have a most deviations. Okay, which have a most deviation. So what is the difference between the least deviation and most deviation is that this blue color light having some problems to propagate into with the transparent media. So they are having the shorter wavelength. Okay. Then if increasing wavelength and decreasing frequency, you can see that you will notify that this will be the position for that, and I can tell that increasing wavelength means these are having the shorter wavelength, and these are having the higher wavelength. That's why I am telling increasing wavelength. And if I am telling decreasing frequency, it means this is having a decreased frequency and this is having a higher frequency. Okay. So you have to understand this and write down fast. Okay, next we are understanding our last topic, that is the scattering of light. Okay, first stop writing. See some things here. So once again we have to see that with your, it means the increasing wavelength and decreasing frequency. Then generally you seen in the rainy days in the clear sky. Okay, Vibgyor can be seen. So what is the cause of this formation of Vibgyor? What is the cause of this formation of Vibgyor? So why it is a formation? Because many millions of drops which can act as a small prism. Okay, many millions of drops which are in the clear sky, they are just act as a tiny prism. And what are the what are the refractions and dispersion and reflections can be happen in the tiny drops. So I can draw one diagram of this tiny drops. When a light is passing through this, then there is a refraction. So refraction will be start here, then converted of this. So you can tell this is the dispersion. Then again this is the TIR, that is the total internal reflection. So these millions of drops which act as a tiny prism, because you know about that in the tiny prism there is a refraction, and due to this refractions and dispersion, refraction is just a bending of light, and due to this dispersion, splitting of light into the colors. Okay, so due to this color changing and total internal, so first the light rays which is coming, and this figure only seen when in front of the figure will be seen, and in your back side there is a sunlight availability. Okay, so when the light is entering into this tiny drops, then refracted and getting many dispersion, it is just dispersion inside this tiny drops, and you generally see in the bubbles of any source solution or like that. This is refraction generally take place, and then total internal reflections also place. Okay, total internal reflection. Okay, and then again when these light rays in the form of 7 its constant color coming out from the tiny drop, then it is the getting the again refracted. So these all are it means the process happening in this thing, and the figure can be formed. Now there is a scattering of light, that is the throw of light in the random direction, and this scattering is generally seen that in the forest area, in the canopy of the forest. So they are just showing the scattering of light. It means the throw of light in the random direction. Any direction light can be throwing, and this is the Tyndall effect. Throw of light in random directions due to particles in its path. So you see that if one glass of one beaker which is filled with the water, okay, or maybe the different type of solution, if their particles are bigger than, okay, they are just refract the light into the another side, and you will not get a complete beam of light. So due to the particles, if light gets refracted, due to this particles, if light gets refracted, then it is known as the Tyndall effect of particular nature. So if the particles are very bigger in size, then lights are refracted. If particles are smaller in size and very minute particles that you can see in the salt solution or sugar solution, that cannot be refracted too much light. But if some crystals or like potassium perfected like that, then they can refract the light in the different direction, and the complete light which is starting from here cannot be get into the back this side. Okay, 2-3 questions you will see in your books regarding the scattering of light, dispersion of light. You also already know that about the how figure is formed, okay, and how what are the process behind the cause of this figure. So now why sky is blue? At noon sunlight is white in color, and at sunrise and sunset the sky red in color. So what are the reasons why sky is blue? So look, why sky is blue? Because when the sunlight is coming from towards the earth, okay, most of blue light is scattered initially. It means most of blue light is scattered initially. It means you also write this for answer. Okay, it means the sunlight is a white in color. So first deviations or most deviation can be formed in the violet or blue light conditions. Okay, it means blue light color. Okay, so when the white light is coming from the sunlight, blue light scattered most. Blue light scattered most, and due to that all blue light are just scattered initially. That's why all the sky is just look like a blue in color. Okay, and astronauts cannot be seen this sky color is blue because for the scattering we need an atmosphere. For scattering we need an atmosphere, and at the universe, okay, there is no atmosphere, and due to there is no refraction and scattering of light, okay, and so all the colors are look like a black in color. Okay, so the astronauts look the space generally black in color. At noon time sunlight is white in color. It's देखिए इसका रीजन ये है कि देखिए नून के समय जो लाइट है, सन की लाइट जो है हमारे ओवरहेड पर रहती है, ठीक है, और जितनी भी सारी लाइट है, ऑल लाइट्स, ठीक है ना, विदाउट रिफ्रैक्ट हुए, विदाउट स्कैटर्ड हुए, ऑल लाइट देखिए हमारे पास में पहुंच जाती है. ओके, व्हेन दे आर ट्रैवल लॉन्ग डिस्टेंस, देन their blue light are scattered most and red light are remaining here. But when they are travel the less distance to the overhead, then there is no refraction, no reflection of light, then all light comes to the earth. That's why daytime or noon time you see that sunlight is a white in color. At sunrise and sunset the sky is red in color because they are like that. This is the sunrise time, okay, and you are standing here like that. This is the sunset time, okay, and this is the sunrise time. Okay, so this is the formation of one horizon here up to your position on the earth. Okay, so when the light is traveling from here, very minute particles are there. It is the only blue color. Most light are can be scattered on that time, and the red color, which is just coming and having a longer wavelength, and least deviation. Due to that red color, and from this also a red color only can be seen by the us. Okay, so this is the reason for that to why sunrise and sunset time sky is a red in color, because the blue color light was scattered before that. Due to that many more the size of bigger particles, and then the smaller particles have different type of optical densities. They are not deviate the red colors, and this red color can be reached to our eyes. Okay, so first of all you have to write, and doubts can be asked.